Okay, so get this. Scientists are saying we could be making materials even more valuable than diamonds. And the building block as well.
What is it?
Pencil lead.
Wow.
Just plain old graphite.
It really does make you think what else is out there.
I know, right? This deep dive is about this paper from Tel Aviv University called Scientists Just Discovered a New Way to Transform Matter. It was published February 9th, 2025.
Interesting.
And it's not just some boring academic paper.
No.
It's a completely new way of thinking about materials.
So we're not talking like alchemy turning lead into gold.
Right.
But it's almost as crazy.
So no magic spells, it's just some really serious science.
Exactly.
Okay, I'm intrigued. How does graphite become more valuable than a diamond?
Well, think about it. Diamonds and graphite are both just pure carbon.
Right.
But their structure is totally different.
Yeah.
Diamond is so tightly packed, that's why it's hard and sparkly.
Right.
But graphite is loosely bound in layers, so it's soft and you can write with it.
Okay, so rearranging the atoms is the key.
Yeah.
But diamonds need huge heat and pressure to form.
Right.
We can't do that in a lab, can we?
Well, that's where the Slidetronics comes in.
Slidetronics.
Yeah, this Tel Aviv team figured out how to manipulate the forces between the layers of graphite.
Okay.
So they can basically slide them around to make new materials.
Slidetronics, it even sounds cool. But how do you actually slide atoms?
Well,
do you use tiny tweezers?
Not quite.
Okay.
Think of the layers like sheets of paper.
Go on.
Each sheet is a layer of carbon atoms. And they're held together by these things called van der Waals forces, which are pretty weak.
Right.
And by using really precise electric fields or pressure, they can make these layers shift and restack in different ways.
So you're saying they can build new materials like atom by atom?
Yes.
Like tiny Legos.
Exactly. And the crazy part is these shifts happen in these little jumps.
Wow.
Just one atom's width at a time.
So they click together.
Yeah, into stable positions where the atoms all line up perfectly.
That's amazing. So they aren't turning graphite into diamond. They're making something totally new.
Right.
These polytype materials, what's so special about them?
Well, it's not just making different materials, but materials with properties we can control. These new configurations can even store information.
Really?
Think about it. Tiny, super efficient memory units, all because of how the atoms are arranged.
So what else can they do with these atomic Legos?
Well, they're trying different numbers of layers and different types of atoms.
Okay.
Imagine this. 3 layers, 2 different types of atoms.
Okay.
That can make 6 different materials, each with unique properties.
6 materials from just 3 layers.
Yeah.
That's wild. And it just multiplies when you add more layers, right?
Exactly. With 5 layers, they can make 45 different structures.
45.
And this even plain old graphite can be rearranged into 6 forms, each one with different electrical, magnetic, or even superconducting properties.
Wait, superconducting from graphite.
Yeah.
So 0 electrical resistance.
Exactly.
That's like straight out of science fiction.
It really shows you how much potential is hidden in these materials we think we already understand.
But I bet it's not all amazing discoveries and easy sliding.
You're right.
What are some of the problems they're facing?
Well, one of the biggest is stability.
Okay.
They have to make sure those layers stay put.
Right.
And don't just randomly rearrange themselves.
Especially if you're going to use them for real-world things.
Exactly. You don't want your super efficient memory suddenly rearranging itself.
And losing all the data.
Yeah. So the team in Tel Aviv is working on refining their Slidetronics technique.
Okay.
Making it more precise and reliable.
So they're fine-tuning their tools to become like master atomic architects.
Yes.
Okay, I'm really interested. Now, what's next for this research? What are some of the potential applications?
Well, we already mentioned computing.
Right.
But it goes way beyond that.
Like what?
Energy storage, new types of sensors, even advances in medicine.
So we could be revolutionizing tons of industries.
Exactly.
I'm already hooked. I can't wait to see where this goes. But before we get to all that, I think we need to zoom out a bit.
Yeah.
And think about the bigger picture.
You're right. It's not just the what, but the so what.
Exactly.
What does this mean for us?
Right. What does this mean for the future?
Exactly.
So for everyone listening, think about this. If we can unlock this crazy potential from something as basic as graphite, what other everyday materials might have extraordinary possibilities hiding inside them?
It really makes you wonder what's next.
It really does. We'll be back in part 2 to dig deeper into those potential applications and what Slidetronics could mean for our world.
Welcome back to our deep dive on Slidetronics.
You know, when we were talking about graphite's hidden potential,
it
got me thinking, what other materials are we just totally overlooking? What if we've been thinking about materials all wrong?
That's an interesting thought.
Right. Like instead of this is what this material is,
Yeah.
what can it become?
Exactly. It's like we've got this whole new toolbox.
I like that analogy.
Speaking of toolboxes, let's talk more about these polytype materials.
Okay.
The name might sound a little technical.
It does.
But the idea is actually pretty simple.
Right, and I think that Lego analogy really helped.
Yeah.
So just to make sure everyone's on the same page,
Sure.
these polytype materials are made by rearranging the atoms inside right.
Exactly. Like, think about a stack of Legos.
Okay.
Each brick is a layer of atoms. And you can build all kinds of different stuff just by moving those bricks around.
Right.
That's basically what they're doing with Slidetronics, but with atoms.
So instead of being stuck with what a material already is,
Right.
we can just make it into whatever we want.
Pretty much. It's like tailor-made materials.
That's amazing.
Yeah.
And you said we could change all kinds of properties.
Yeah, electrical conductivity, magnetism, even superconductivity.
Wow. That's like a material that can shapeshift?
Kind of.
Okay. I'm sold on the idea, but how does it actually work? Do they just like push on it or zap it with electricity?
It's definitely more complicated than that.
Okay.
Electric fields and pressure are tools they use.
Uh-huh.
But there are other cool techniques, too.
Like what?
Well, one is called chemical intercalation.
Chemical intercalation.
Yeah.
That sounds kind of scary.
It's not so bad. Imagine those sheets of paper again.
Okay, the atom layers.
Right. Chemical intercalation is like slipping other atoms or molecules in between those sheets.
So they're putting tiny spacers between the layers.
Basically.
What does that do?
It lets them change the spacing between the layers.
Okay.
And how they interact with each other.
Oh.
It's like adjusting the tension on a guitar string.
Ah, so a tiny change can make a big difference.
Exactly. And by tweaking those interactions, they can fine-tune the material's properties.
It's like a microscopic tuning knob.
Yeah. And that's just one technique.
What else?
They're also using lasers and electron beams to move those layers around even more precisely.
Wow, so they're using light and even subatomic particles to build materials.
Exactly. It really combines physics, chemistry, materials, science, and engineering.
It sounds like it takes a whole team of geniuses to pull this off.
It does. But all this amazing science has to have some real-world applications, right?
Right. What's Slidetronics actually doing for us right now?
One area where we're seeing a lot of progress is energy storage.
Like batteries.
Exactly. Imagine batteries that charge faster, hold more energy, and last longer.
Now that would be a game changer. How is Slidetronics doing that?
Well, remember how we talked about fine-tuning a material's properties?
Yeah.
They're using Slidetronics to create materials with much better ionic conductivity.
Oh, for those of us who aren't scientists, what does ionic conductivity even mean?
It basically means how easily charged particles can move through a material.
Okay.
And that movement is super important for how batteries work.
So they're making materials that are like super highways for those charged particles.
That's a great way to put it, and they're already seeing great results.
Like what kind of results?
They've created materials that are way better than what we use in batteries today.
So what does that mean for us?
Well, think about electric cars with way more range.
Okay.
Or phones that can go for days without charging.
Wow. And it's not just consumer electronics, right?
Right. It could change how we store renewable energy.
Okay.
Power medical devices, all kinds of stuff.
So this could revolutionize energy.
It could.
Right.
And Slidetronics has potential beyond just batteries.
I was just thinking that.
Yeah.
What other areas are they working on?
Another exciting one is sensors.
Sensors.
Imagine sensors that are super sensitive and specific.
Okay.
And can detect way more things than we can today.
What kind of things?
Well, pretty much anything you can think of.
Hmm.
Pollutants in the air, diseases in the body, even whether food is safe to eat.
Okay, so these sensors could make us healthier and safer.
Exactly.
It's like Slidetronics is giving materials a way to communicate with us.
Kind of. They can respond to all sorts of things in predictable ways.
This is incredible. But I know there have to be some downsides.
You're right.
It can't all be sunshine and roses.
Right.
What are some of the challenges with Slidetronics?
Well, one is scale.
Okay.
It's one thing to make these materials in a lab.
Right.
But making enough for everyone to use is a whole other challenge.
It's like the difference between baking one perfect cookie and running a factory.
Yeah, exactly.
Yeah.
Keeping that level of precision and quality at a large scale is really tough.
So they need to figure out how to make a lot of these materials and make them affordable.
That's right. And another challenge is making sure these materials last.
Okay.
Those atomic layers need to stay put even when they're out in the real world.
Right. You wouldn't want your super battery to suddenly fall apart because the atoms shifted.
Exactly.
Yeah.
So a lot of the research is focused on making sure these materials are stable and durable.
It's a tough balancing act.
It is. You want to push the limits of what's possible.
Yeah.
But you also need to make sure the technology is reliable and practical.
It's been amazing learning about Slidetronics so far.
I agree.
We've talked about how it works, what it can do, and even some of the problems.
Mm-hmm.
But before we wrap up this part, I think we need to zoom out again
Okay.
and think about the bigger implications.
You're right. It's not just about the applications.
Yeah.
It's about how this changes the way we think about materials.
It's like we're entering a new era of material science,
Mm-hmm.
where we can create anything we want.
Yeah. It's not just about what nature gives us anymore.
Exactly. We can design and create materials with unbelievable precision.
And that opens up so many possibilities for solving big problems.
Right, like energy, healthcare, the environment.
Exactly.
So for everyone listening, think about the transformative power of this.
It's not just about cool gadgets.
It's about creating a better future.
And as we learn more about Slidetronics,
Yeah.
we'll keep exploring those possibilities and what they mean for our world.
So join us for part 3 as we dive into how this revolutionary technology could change everything. Welcome back to the Deep Dive.
Yeah.
We spent the last 2 parts digging into Slidetronics, how it works, what we can do with it, and some of the challenges.
Right.
But now I want to talk about something even bigger,
What's that?
the implications for our future.
So what?
Exactly. We've talked about the economic stuff.
Huh.
Like, Slidetronics could create whole new industries,
Yeah.
but it could also wipe out old ones.
That's true. Think about mining and manufacturing.
Right. It's a two-sided coin.
Like most new technologies.
Exactly. The key is being ready for those changes.
I agree.
Things like education and retraining are going to be super important.
So everyone benefits.
Exactly. And speaking of benefits, we need to talk about access.
Right.
If we're making these super valuable materials,
Yeah.
how do we make sure everyone gets them?
That's a good point.
Not just a lucky few.
We've seen what happens when resources are controlled by just a few people.
It leads to inequality and conflict.
Exactly.
We need to be careful with Slidetronics.
To make sure we don't repeat those mistakes.
I think open collaboration is key.
Definitely.
And transparent governance.
Yeah.
We need to make sure everyone benefits from this.
Agreed. We don't want Slidetronics to become like the next diamond industry.
Right, where a tiny group controls everything.
Exactly. We have
Yeah.
to learn from the past.
Okay, let's zoom out even further.
Okay.
How could this change our everyday lives?
In lots of ways.
Right, our interactions with the world, even our sense of self.
It really blurs the lines between the physical and the digital.
I see what you mean.
Imagine clothes that change with the weather,
Wow.
or buildings that can change their shape.
Huh. It's like the world becomes dynamic.
Yeah, like an extension of our thoughts.
That's a huge change. It would change how we design things,
Mm-hmm.
how we experience the world around us.
Even how we interact with each other.
But that much control over matter has to come with some ethical questions.
Of course. Any technology this powerful has to be used responsibly.
So what about misuse?
Right. We need to think about unintended consequences.
Like blurring the lines between what's natural and what's engineered.
It's like opening Pandora's box.
There's potential for good, but also for bad.
We need to make sure Slidetronics benefits humanity.
And doesn't become a tool for control or manipulation.
Exactly. This isn't just a question for scientists.
Right.
We need a bigger conversation.
Everyone needs to be involved.
Policymakers, ethicists, everyday people.
This isn't just about the science.
Right.
It's about our values.
Our priorities.
What kind of future we want.
Technology is never neutral,
It's a tool.
and the way we use it shows what we care about.
So as we get excited about the amazing things Slidetronics can do,
Yeah.
we also need to remember our responsibility
To make sure it's used for good
to have those tough conversations.
and to work together.
So Slidetronics gives us a peek into a future where the world is more dynamic and responsive.
A world that meets our needs.
But we have to be smart about it.
We need foresight
Responsibility.
and a commitment to making a better world for all.
Well, that about wraps up our deep dive into Slidetronics.
It's been a fascinating journey.
We hope you found it insightful.
And thought-provoking.
Maybe even inspiring.
As we learn more about the material world
Let's do it with a sense of wonder.
and curiosity.
And remember to use our knowledge wisely.
Thank you for joining us.
We encourage you to keep learning about Slidetronics.
And to have those important conversations.
After all, the future is what we make it.